Welcome to my channel Amateur Radio Universe. Today in this video I am going to talk about frequency counters and how to build one. In an amateur Radio Shack there is a need to understand the frequency of radio frequency oscillators, radio receivers and transmitters. Therefore a frequency counter will be a useful piece of equipment for this purpose. A frequency counter is an electronic instrument used to measure frequency. Frequency counters measure the number of cycles of oscillation or pulses per second in a periodic electronic signal. It accurately measures the frequency of signals that have sinusoidal, square wave, triangular wave, sawtooth wave or other waveform patterns. They can measure frequencies and timing characteristics of both analog and digital signals. The different parameters of a signal that can be measured by a frequency counter include frequency, period, frequency ratio, time interval error, pulse width, rise and fall times, phase angle, duty cycle, voltages, signal power, etc. Parts of a frequency counter. A general purpose frequency counter has some form of amplifier, filtering and shaping circuitry at the input. DSP technology, sensitivity control and hysteresis are other techniques to improve performance. The different parts of a frequency counter are input conditioning and threshold unit, AND gate, counter or latch, accurate time base or clock, decay dividers, flip-flop and display. Operation of frequency counter. Frequency counters are very accurate and precise. They work by relying on an internal electronic oscillator called the time base that serves as a time reference for the frequency measurements. Most frequency counters work by using a digital counter to count the number of rising and falling signal edges occurring in the measured signal within a specific period of time. This specific period of time is called the gate time. At the end of the gate time, the accumulated count is transferred to a holding register and the counter is reset to 0 to prepare for the next measurement. The value stored in the holding register directly indicates the measured frequency in Hertz when the gate time is 1 second. For other gate times, the holding register value must be scaled to convert it to Hertz. In digital frequency counters, the measured frequency is typically output to a display. Period measurement is done by measuring the time required for an integer number of cycles rather than counting cycles for a constant gate time and dividing that time by the number of cycles. At high frequencies, a frequency counter uses a prescaler that reduces the frequency, which helps to read the output. The accuracy of a frequency counter is dependent on the stability of its time base. The time base stability may be degraded by vibration, electromagnetic interference, drift due to age, and temperature variations, thus making the measured frequency displayed higher or lower than the actual value. Today we have a frequency counter. It's a kit build type. I have built this using buying it from a kit, a frequency counter kit, and it's written as a frequency counter and as a crystal tester. So it it has two purposes, which is it can be used as a frequency counter and as well as as a crystal tester. So this is it's a peak based frequency counter, and the display is a 7-segment LCD display. As 1, 2, 3, 4, 5. Five LCD displays are it is given, and the other components in this board, other than the PIC IC, we have the 20 megahertz crystal oscillator, and we have a variable capacitor to adjust the frequency. This is the micro switch, push button switch. Then we have few passive components, few resistors and capacitors, and this is a voltage regulator IC, and this is the input signal input, the ground and the signal line, and this is the power input and just given through a jack. So these are the basic setup here, basic the details of this frequency counter. It can measure a frequency from one, it states that from 1 hertz to 50 megahertz. So that is a frequency range that it can measure. So we also have here a Hartley oscillator. This is a Hartley oscillator. This is the oscillator stage, and we also have 3 amplifier stages. It's an all it is a broadband. It is arranged, all those transistors are arranged in a broadband mode. It can amplify frequencies from the lower frequency to up to 50 megahertz. It's wired in a broadband mode, so it has a higher bandwidth of amplification. And this is the power socket here. So I'll just connect the frequency counter, and we have the signal input line given here. This is the ground line. This is the signal input power line, signal input line. So just put the power. So you can see showing the LED, the counter is on. So now I'll connect the power jack here. So we have given a oscillator coil, which is it is in the lowest frequency range. It shows in this coil it can give a lowest frequency range of 3 megahertz, 3.25 megahertz. So I can change. This is a variable capacitor. I can change it to a higher value up to 8 megahertz. I can adjust up to 8 megahertz. From 3.25 to up to 8.49 megahertz. So now I'll just take out the oscillator coil and use another coil.